Welcome to the next installment of Listening to the Wind, the IWSA regular interview series. And I'm very pleased to welcome today HSVA from Hamburg and Jan Lassen and Jorg Brunswig. Welcome to Listening to the Wind.
Thank you.
Thank you.
Yeah, I'm really looking forward to hearing about what you've been doing. But before we do, I'd just like to quickly introduce Jan and Jorg. So Jan Lassen is a naval architect and joined HSVA back in 2013. He's a maneuvering and CFD expert and specializes in special non-standard projects, and is a core developer of EcoLibrium, I hope I've got that right, along with Jorg. Jorg Brunswig is a naval architect too, with HSVA since 2015, and is a specialist in lines design and optimization, and of course a CFD expert too. So I think, gentlemen, we're in very good hands today, and I'm really looking forward to this presentation. So without further ado, I'm going to hand the reins over to you, and I'll see you on the other side.
Thank you, Gavin.
Thank you very much. What was the right order? Starting this and then sharing screen. Oh.
I think you have to go into the Zoom window and then press Alt S. Right.
Window.
Now that should work.
That should work. It should be that screen. Oh, sorry, so many screens. Yeah, thank you, Gavin, for the introduction. And I'd like to start with a short presentation about what HSVA does, and of course focus on what HSVA does with respect to wind-assisted propulsion. Well, let's be in focus. Okay, so as you can see here, we have quite a number of different facilities. Of course, we have the classical model test basing where we do resistance and propulsion tests, maneuvering, seakeeping, and stuff like that. And we have workshops for building our models, a mechanical workshop for building propulsion systems and things like that. Then we have a facility where we carry out our CFD calculations, a computational cluster with, I think it has 1,500 CPU cores right now, because CFD is a quite important field for us, of course. Then we have a test tunnel for very specialized tests regarding propeller design, where we can provoke cavitation and test cavitation, and we have ice testing facilities. So the services we offer with these facilities are, of course, model tests. We can do all kinds of simulations. We support our customers by doing hull designs or hull optimizations, and in general, we provide expert consulting for our customers. The main facility, of course, is the large towing tank. It's 300 meters long, 18 meters wide, 5.5 meters deep. The carriage can go up to 10 meters per second. And we can create waves in the large towing tank. We have a longitudinal wave maker at the end, and we have a certain region where we can also create transversal waves. And as I said before, we do resistance and propulsion tests in this tank, maneuvering tests, seakeeping tests. But of course, and that's a very important point, we are always prepared to adapt our gear for special projects. One of the most important parts or devices in the large towing tank is the computerized planar motion carriage. That's a device that gives us the ability to control the attitude of a model. And for sailing vessels, This is very important, for example, if you want to look at drifting vessels and the forces that come from drifting sailing vessels. With pre-calculated or somehow predetermined aerodynamic forces, we can apply those as external forces on the model to also get some interaction for these systems. Regarding the aerodynamic side, we have the very beautiful situation here in Hamburg that just across the river Elbe, we have a very sophisticated wind tunnel at the Hamburg University of Technology. And whenever we have projects like projects around sails or aerodynamic topics, we very much like to cooperate with them. Their wind tunnel has a cross section of 3 by 2 meters, can go up to a major storm speed of 35 meters per second, can run in different operational configurations, open or closed circuit. And of course, they have all the modern technology like 6-stop balance, PIV, LDA, pressure gauges, whatever. So this is really an technically up-to-date wind tunnel. And in terms of sail analysis, of course, you can use that wind tunnel to determine polar data for wings, sails, but you can also put ship models in there and learn something about the sail-hull interaction or the interaction between multiple rotors. And that's why we brought this rotor here from the wind tunnel. Let me switch this on. I hope it runs now. It's still in standby.
There you go.
Yeah.
There you go.
Just to show something, some hardware, really. That was.
And that hardware has been in the wind tunnel. It
has been in the wind tunnel. Here, actually, we're running it at the very, very low RPM. In a real test, of course, it would. I think they said it would run at something like 10,000 revolutions per minute. Here are some more impressions from the wind tunnel, the big turntable, so that you can get these polar data out of measurements. And another nice movie, I think that's very likely a particle image velocimetry measurement here. So then, of course, another very important field for us is simulation methods, and our major workhorse here is the Finite Volume CFD code Fresco Plus, which is an in-house development. I think it has been around now for 15 years or something like that. Was developed in cooperation with Technical University in Hamburg. It's a multi-phase solver, so you can float things. It works on fully unstructured grids, so it's quite easy to deal with complex geometries. It has different turbulence models, of course, and we can choose depending on the level of detail, basically, that we need. This tool is routinely applied in basically all our industrial design projects, and so that's why we see it as basically our virtual towing tank and our virtual wind tunnel. The pictures here show some example results: a container vessel moving in some sea state. At the bottom right, we see pictures from an optimization campaign where the topic was exhaust gas dispersion for research vessel. And I guess the top right picture is about aerodynamic drag of a container vessel. Using this tool, we have carried out many numerical studies for merchant vessels retrofitted with sails. In the virtual world, of course, it's quite easy to set up the atmospheric boundary layer. I think it's even a bit easier than in the wind tunnel, actually. If necessary, we can dynamically allow for free roll, trim, and sinkage of the models. And you can do parameter studies using that technology regarding different geometric configurations, wind speeds, rotor speeds, whatever. We have to say, though, that this is an expensive and resource-hungry tool. So doing parameter studies like that will take, or can take, weeks. It's not a matter of minutes, of course. The pictures here show some example results in an EU project targets. We retrofitted a tanker, a project tanker with wing sails. And on the bottom right, you see a bulk carrier retrofitted with rotor sails, just to look at the interaction between the hull and the rotors. Because this method is so resource hungry and expensive, we decided to develop a system approach tool, a modular velocity and power prediction tool, which we called EcoLibrium. The purpose is to assess the performance of vessels equipped with sails in general, and it does that by a superposition of all relevant forces and moments that are part of the system, and it solves these forces and using the degrees of freedom for a quasi-static equilibrium. Force modules can be pre-calculated response surfaces. It can be data coming from our HSVA database. It can be handbook methods, simple equations for some appendages that we know. In general, we can use data from experiments and CFD, of course. The entire program was designed initially to be as easy as possible to extend, because at the moment, this wind assistant propulsion topic is gaining momentum, but we don't know yet where it's really going and which kinds of crazy wind propulsion devices will come across in the next years. So it was very important for us that we have an application that we can easily extend and adapt to future situations. Scenarios of applications are, of course, to compare different wind propulsion devices, optimize the configuration and positioning on deck. For our customers, of course, it's very important that we accurately predict savings. And this tool can also provide the required input for route optimization tools. And we believe that route optimization will play a very, very important role in this wind propulsion area. On the right-hand side, you see some example results with arrows indicating which force modules produce forces in which directions and how strong. And at the bottom, you see some polar plots with possible power savings and the total remaining power demand of the entire system. That came from some internal studies, I think from a bachelor thesis that was done here recently. Example, wind-propelled vessels. I think everybody in the maritime industry has seen or has heard about the Indosail project. It's a quite old project. I think it's from the 80s. The goal was to build, design and build sailing vessels for Indonesia. I think the smallest one, at least, which we see here, was built. And of course, I mean, I wasn't at HSVA at that time, but for me, it definitely would have been the greatest fun to take part in the model tests on Lake Ulster, which is the lake right in the center of Hamburg.
I was born that year.
Yeah. A much more recent vessel is the E-Ship 1. It's a specialized vessel for the transport of wind turbines with a length of 130 meters. It has 4 Flettner rotors, is in service since 2010, and HSVA was involved with hull design and optimization, model and wind tunnel tests. So to wrap it all up, what are the services that we would like to, or we can provide to our customers? In an early project phase, we have the tools to analyze the potential of different wind-assisted propulsion concepts. We can estimate savings and costs, which are very important for the owners. And we can also perform a risk analysis. Later in the project, we of course can also look at much more at the details. We can optimize hull designs. We can carry out computations, allowing us to provide more accurate input for the system modeling tool based on CFD or model tests. And of course, a very important topic for us is always the interaction between different appendages and propulsion devices and the hull and so on. So yeah, that basically wraps it up, I think.
Oh, fantastic, fantastic. Very interesting presentation. Thank you very much. I'm always just amazed by those parameter studies. The detail that you guys can generate. It's quite incredible. But the EcoLibrium project, kind of making a sort of, as far as I could understand that, it's more user-friendly interface, and a cheaper way, maybe a cheaper way to get your baseline information.
I think, well, we initially, as Jorg already said, the idea or intention behind the software was, for now, it's just for ourselves to be able to have a modular concept where we can throw in any kind of forces that can come from anywhere, basically, be it simple formulas or be it actual test results from the basin. And that allows us to combine those and do polar diagrams and do a prediction on the power savings on a route, actually. And that's very important as we think. And it's very important for us that we have the control to adapt that kind of a software, and that we have control in how the actual models interact. And we paid a lot of attention to making sure it's really easy to adapt, but you still need to be writing some code there. So
yeah,
so it's not for idiots like me. So
I don't know. I guess so. Well, yeah.
But I had a lovely image there of you carrying one of the ship models across the Elbe or under the Elbe through the tunnel to the Hamburg University. But that's a fantastic facility to have so close by.
Yes,
absolutely.
How often do you actually use that? I mean, is it used quite regularly now?
That's a good question.
That's a good question. I think we would like to use it more often. And of course, we hope that this wind propulsion topic brings us more often together with them. So
I think in the past, what we always look at is the superstructure of super yachts, for instance, or research vessels. That's always there have been wind tunnel tests looking into that. But from actual wind assisted propulsion tests, that's very rare.
Yeah.
I would say.
Yeah. Well, I think it's going to become less rare.
I hope so. Yeah, that's
in the very near future. Yeah. Well, I actually visited HSVA quite a few years ago with my good friend Peter Schenzler, and saw the towing tank and the model construction area. And I was just wondering, things seem that was probably 8-9 years ago.
Okay.
Things seem to have moved on quite a bit. So probably around the time that you were joining HSVA, what elements of the work that you're doing have really changed over that sort of maybe the last decade? Because I'm seeing a lot more sophistication here than I did previously.
I think that's really crucial. I think like from a more general testing concepts, we're now to all the concept design is being done in computers and tested in the computers already. So what we are looking at is verifying those numerical models and also paying a lot of attention to the details and like the fine optimizations. And so that's very, very important to get like super accurate measurements and to have very, very reliable data for the numerical tuning. That's very important. I think that's a major change. So introduction of the computational power CFD and combining that with our test facilities, that is, I think, one of the big changes in the last decade.
And I also think that we see more and more special projects that are really not standard, not the classical resistance and propulsion test only.
It might be that we're too expensive to research those, could be, but like also the special projects are a lot of fun to do. Like it's a little trickier, of course, but yeah, it's very challenging sometimes and very, very interesting to do. As an engineer, this is a super playground.
Well, I think we've, at least in my experience, when I talk with naval architects, those coming in today into the industry, I mean, pretty much all the parameters are up for discussion, different equipment that's coming in, new designs. Yeah. 10, 15 years ago, pretty much you just had a Bolker, it's a kind of, I want an oblong with a pointy bit and big engines, and please design that. But now, actually, it seems that there's so much going on in the maritime field that come in, bring your imagination.
Yeah, I think a word that really fits is optimization. Like we're not seeing any ship haul around that's going into the basin without having seen any kind of numerical simulation beforehand. So that's always key and is always done beforehand until we see it here and doing the expensive tests.
And that brings me to one of the questions that I've got for you, sort of widening this out a little bit to the industry. Do you think the industry is moving quickly enough into this decarbonization world, or do you think there's still, for applications at least, do you think they're still quite conservative, moving slowly, incrementally, or do you think there could be some major changes coming in the near future?
I think that's a super question. I believe that as an engineer, it's always easy to see that the technical barriers have been overcome, kind of, right? So we have some solutions. We see that these things are working. But yeah, so from an engineering perspective, I would say, no, we're not moving fast enough. We could be a lot faster, right? So we need to be a lot faster. And so the question is rather what stops us from being faster? And I know I've been thinking about this a bit. I think de-risking is really key, and de-risking investments, but also operations. It's not just limited to designing the ship, but it's also running. And we have rather little experience in what's going to happen with all those wind-assisted propulsion devices when they're in service. And that's very difficult to predict. So there's a little uncertainty, I would say. And of course, we can, from a design perspective, do a lot for de-risking.
Yeah, we see that as our job, basically. I mean, we can very well understand that our customers want to know about the involved risks with wind-assisted propulsion, because if you have a ship lying in the harbor for 1 or 2 days because something is not working with the wind propulsion device, that might cost more than the entire device itself. So I can perfectly understand that they need to know a lot, and we see that as our job to also provide that knowledge.
The public funding that is available right now that already exists is targeted towards the technical installations, and it's not so much targeted to the actual operations. Of course, that's super tricky. How would you do that? But I think that's we need to have some solutions for that.
No, I wouldn't disagree. I think, and I'm starting to see some of the Horizon projects in the EU looking more beyond just the installation, looking at the operational aspects. And of course, we're seeing sort of more hinge devices, movable devices, retractable devices, looking at those operational aspects as being key as well. It's all well and good when it works well, but when it's important, being battered around a little bit needs to be robust as well.
We know from testing experience that things tend to break always.
Yeah. And you engineers love testing it to braking anyway. So
yeah,
Sure.
we test until it breaks.
Yeah, sure.
We need to
But
test. That's our job, right?
That's true.
But I think what you mentioned there about de-risking, and I think that this is, all the way down the line. I mean, obviously my job is around sort of in a sense demystifying wind propulsion, but that de-risking in a financial aspect, in a technology aspect, in a safety aspect, all of those things in a regulatory aspect, I think that really is, it's a good indication that these things are moving forward.
Yes.
And, it's a natural progression to want that
right.
de-risking.
Yeah. And they are moving. We are seeing more and more interest coming from our customers very often about these rotors. And
Yeah.
I'm pretty sure that's because if there is a problem, you can just switch them off. You don't have to reef them. I mean, what could go wrong? With these?
Yeah, and I can see it's still going around on the table, which is great as well.
Yeah.
This is the most action interview I've done. It's great. It's excellent. I love it. But we were talking about that de-risking. Are there any significant barriers, from an engineering or a technical aspect that exists for wind propulsion technologies? And with that, the scaling of these, at the moment we see most of the installations are relatively small compared to the size of the vessel. So as with wind turbines, I can imagine that the scale is going to increase in the future. Are there any considerations or concerns around that?
I don't know, you want to start?
I think we don't see any, from a purely technical point of view, we don't see any hard barriers. We see challenges, of course, and things that need to be solved and optimized and then finally tried on a deck. But we don't really see any strict barriers that would completely block the development of wind propulsion in merchant vessels.
I think
so. Please go ahead.
Yeah, I think like what's not so understood right now is maybe as we increase with the power that's coming from the wind, how do we maneuver the vessels in congested areas? So that's going to be a tricky. It's not so much an engineering challenge than it is a safety challenge. But how are we going to do and do that? And of course, like we can attach maneuvering devices that can help. I don't know, make sure that the ship can actually maneuver safely, but that might not be enough, especially when you think about storms or big waves, what have you. So I think that might be a challenge, but it's not a barrier.
Yeah. And I thought, during your presentation, you were talking about that integration of, things like rudder, propeller, wind propulsion, the interactions with the deck and with the sides of the vessel, your lateral forces, all of these aspects are something that's quite, I wouldn't say it's not new to the industry.
No.
It's been around for a few thousand years, but it's newly important. And the size of vessels we're talking about today are absolutely huge, some of these. So with that integration, I mean, are there challenges around creating sophisticated enough models to take all of that interaction into a whole?
Do you want to answer?
I think the important point is that you can not only think about all that integration and interaction between all these parts in the design phase, but you can really take that technology on board and help the crew operate the ship in an optimum fashion using that technology and that data. And we're actually doing a research project in that direction right now. It's not about wind propulsion, but it's about bringing pre-calculated data on board and highly integrating and helping the crew making the right decisions and optimizing the route and stuff like that. And I think with wind propulsion, that would become much more important.
I think data is somehow underestimated. In shipping sense, right? So there's a lot of data and there's a lot of lessons to be learned using that data, and also not from looking at data that has been measured already, but something how we are going to measure stuff. How are we going to measure? How do we bring all these devices on board, and how do we get all that data back to shore and evaluate those? And that's there are some challenges in that direction, I guess.
Yeah, no, I often hear, you know, the sort of the whole concept of big data, but it seems to be we've got big data, but we don't always apply it. We don't use it properly.
Exactly.
Then, or we're collecting the wrong data for the wrong application.
And I always feel that when you look at the ship and you're being on board and you're in a storm, and it's kind of hard to step back and say, okay, let's look at the data. What do we have here? So that's a challenge.
The data should have helped you not to get in that storm.
Exactly.
Yeah, but there we go. I like the holistic view of that. That's really good. Well, look, gentlemen, that's all fascinating. I'm going to give you some quick fire questions now. Okay, so these are like some 5-minute quick fire. Either one of you can answer, or both of you can answer. Just a quick sentence or a phrase. So, first of all, what's the size of the HSVA team that's working on wind propulsion in particular?
We'd love to have it like really, really big, but for now we're only 4 persons doing it part-time. So there's a lot of interest, of course, but yeah, as the interest grows, the team is likely to grow as well, of course.
And you'll be heading over the Elbe a few more times every day.
Sure.
Yeah,
Yes,
absolutely.
exactly.
They have good beer over there, I think.
Absolutely.
But anyway, how did you personally get into wind propulsion? What you know, did your managers just one day say you're going to do this, or was it something that you really wanted to get involved?
Well, first of all, we're both sailors, hobby sailors, and on your sailboat, you can see how efficient wind propulsion can be. The fact that you can get quicker with good wind, you can quicker from A to B under sails sometimes than under engine. So we know that, and of course, the sustainability topic is a huge topic for us in our everyday work here at HSVA. So it's a natural way towards wind propulsion, I think.
Yeah, I would say the same. So I've been a sailor since I was 8 years old, involved in dinghy racing and whatnot. And so this has been always in the back of my mind, been on my agenda. And I'd love to see this moving forward really, really fast as we possibly can. But of course, that's challenging. We still need to have those projects and the commitment from the customers, right? So
absolutely. So living the dream.
Kind of.
Yeah, that's what I like to hear. That's what I like to hear. What is the most difficult issue that you or your team has had to deal with around wind propulsion or around the testing of wind propulsion?
I think we don't have a specific technical issue. We have the general issue of, I would say, lack of commitment or maybe lack of courage from our customers, which I can perfectly understand, as I said earlier. The markets for them are so difficult to work in, and but we see a lot of interest, but there could be many more projects coming out of that interest. So we would like to see more commitment, and of course it's also our job to convince our customers that they can really take a risk, or that
there's no risk involved, actually.
That the risks are controllable and things like that.
Just takes your credit card, yeah.
Yes.
Yeah, and I think we're in a sense we're seeing that movement now from investigation or interest, actually probably more general interest, into more investigation and analysis. Yeah.
Of course, there's a lot of interest in doing research projects and having like a safe environment where you can do some research and see what works, what doesn't. But like the courage to actually go onto a ship. I mean, with wind-assisted propulsion, that's kind of easier. But when you look at the bigger picture, increasing the sizes, that needs a lot more courage, and yeah, I guess regulation is going to help in that direction.
Yeah, no, I think you're absolutely right. What are the most exciting future design elements that you've seen coming through with wind propulsion technology? Yeah. Oh, so you mentioned crazy earlier on. Crazy design. I like to think of innovative, out of the box solutions, but I take your point. But you know, you've probably seen quite a few things go across your desk in the past. What can you share anything that was particularly interesting that you've seen?
I think, yeah, do you want to answer?
Yeah, I think we always try to, I mean, it's nice to dream of the most sophisticated wind propulsion devices, but what I personally as a sailor always think with everything that's, for example, not a rotor is, how are they going to reef that stuff? What if something is jammed and you cannot reef it, and you know, so I think that many of these very sophisticated devices are not really realistic to be put to reality within 1, 2, 3 years. Maybe I think we will have more development by starting safer, for example, with rotors or with simpler devices, and it will evolve. It will be an evolution instead of a revolution. That's what I think.
So simplicity is the key.
Yeah.
I think what's really fascinating to think about is, as a sailor, when you are alone, no one's around you, and you're on your boat, that's cruising. But as soon as one sail coming up on the horizon, you're in a race. Right? And I'd love to see that kind of idea coming to shipping as well. That would be a fascinating thought. And of course, then we not only have the speed, but also the technologies rivaling each other. That'd be really interesting to see. I'd love to see that, yes.
Yeah, no, it's and we're certainly on that launch pad. You know, there's increasing numbers of reference vessels, demonstrators, not quite there on the liftoff yet, but
right.
I think we're getting there.
We're doing our best.
One question I have that I ask everyone that comes on to listening to the wind, is your wind propulsion team recruiting, or is HSVA recruiting at present?
So HSVA in general is recruiting constantly, depending on, I don't know what actual positions are open at the moment, or whether there are any open at the moment. But I think HSVA is very flexible in that. So as soon as that sector grows and we see that we need more people, HSVA will certainly recruit. I'm pretty sure. Yeah.
We're looking for bright minds always.
Sure.
Okay. All right. I'll look out for some.
Yeah.
For sure. Well, gentlemen, you know, really appreciate you sharing your time, but more importantly, sharing your insights into wind propulsion and design, testing, validating these systems. I'm going to give you guys the sort of last major word, though. So just a couple of minutes. What should we take away from your presentation and your comments today?
Do you want to go for that?
Yeah, I can do that. Well, I think we're living in quite interesting times regarding wind propulsion, with the climate crisis and pressure from regulatory institutions becoming higher and higher, and really changing the markets. And we hope that there will at least be an evolution, maybe someday a revolution in that direction. And we surely want to be part of that. We have all the tools and knowledge and experts needed for thinking about wind assisted and fully wind propulsion, of course. And yeah, are happy to support our customers.
And Jan, I'm sure you agree with Jorg there.
I fully agree. I think we're at the verge of something big here, and I'd love to see it come to reality rather really quickly. And that's what I like to think about. Like when I go to bed, I think about wind.
Hey, me too. So no pressure there. just deliver deliver the market. Absolutely.
Right.
Yeah.
Well, gentlemen, thank you very much for joining us today. And I'm sure that for anybody in the audience, if you have further questions or you'd like to put some business towards HSVA around wind propulsion, I'm sure they'll be delighted to answer your questions and send you further information. And of course, if you have any wider questions around wind propulsion and the market development, regulations, then IWSA and myself, we're always happy to answer those questions. So Jan, Jorg, thank you very much.
Thank you, Kevin. That was a very pleasant interview.
Thank you very much for having us.
No, my pleasure, and fair winds to all.
Fair winds.